Hi everyone, welcome back for yet another exciting online chemistry lesson. Today we're going to talk about pH, and basically not in terms of whether acids have low or high pHs, etc., but where does pH come from? What does it really mean when you say something has a pH of 1 versus a pH of 3? Alright, so let me pull up my PowerPoint presentation. As always, please do watch this video all the way through to the end, because towards the end things will get a little bit trickier, and feel free to email me questions if you have any, or join one of my video question and answer sessions. Okay, so this is actually our last part of our acid base unit. It's going to be about pH, and we're going to talk about what pH is and where it really comes from. So pH stands for potential hydrogen. And the pH scale, as I'm sure most of us know, are used to rank substances in terms of acidity or basicity. So basically, is this thing more or less acidic than this thing, or more or less basic? Now, what pH is based on, again, it's potential hydrogen, is it's all based on the amount of hydrogen ion activity in a substance. So we're going to see the pH scale basically comes from how much hydrogen ions are present. So the more hydrogen ion activity, the more acidic the substance. Now, I like this diagram right here, except for I wish this arrow that comes from like a pH of 6, I wish it actually originated from something more like up here, something with a pH of 1, because what this is trying to show is if you have something that is acidic, the more acidic the substance is, the greater and greater the hydrogen ion concentration is within that substance. The more and more basic a substance is, the greater the hydroxide ion concentration. So you'll see here in this basic substance, there's little to no hydrogen ions. Okay, so the more acidic the substance, the more H pluses are present. The less hydrogen ion activity, the less acidic the substance. Okay, so what we're saying here, the relationship between pH and concentration of H plus. So whenever you see brackets like this, that means concentration. So you would interpret this notation as being the hydrogen ion concentration. Regardless, the relationship between pH and hydrogen ion concentration is inverse. As the hydrogen ion concentration increases, the pH decreases, and that should make sense because the more and more H pluses, acid particles you have in solution, the more acidic the solution becomes. The more acidic a solution is, the lower and lower its pH. We would see the opposite be true. As the hydrogen ion concentration decreases, the pH increases. So as you have less and less hydrogen ions in solution, basically that solution tends to behave more and more like a base when you get down here to the point where there are very, very few or very low hydrogen ion concentration. That's associated with relatively high pHs or basic substances. Okay, don't panic. I am not going to make you calculate pH values. I'm not going to. But in order to understand where pH values come from and what they really mean, I have to at least show you the equation for calculating pH. The pH scale is actually logarithmic. The pH of any substance is calculated by taking the negative log of the hydrogen ion concentration. So if you want to do this at home, you could go ahead and try it. If you pretend the hydrogen ion concentration is 0.001 molar and you take the negative log of that number, it's 3. If the hydrogen ion concentration is 1 power of 10 greater, 0.001 molar, if you actually take the negative log of 0.01, you would calculate the pHs too. So pH values are calculated using a logarithmic function, and again, all is based on that concentration of hydrogen ions in solution. All right, so I said you were not going to have to calculate pH values, but I do need you to understand how does the pH value relate to the hydrogen ion concentration. So again, this is a logarithmic function. That means that every whole pH value, 1, 2, 3, represents a change of 10 times the hydrogen ion concentration from the previous value. So basically, every time you change the pH of something by one whole number, you're either increasing the hydrogen ion concentration by a power of 10 or decreasing it. So for example, if I say I had a pH, something with a pH of 6, and I wanted to make it something with a pH of 5, or I want to compare it to something with a pH of 5, the substance with the pH of 5, which is more acidic, would have 10 times more hydrogen ion concentration, 10 times higher hydrogen ion concentration than the substance with a pH of 6. So let's look at it this way. If you had a substance that has a pH of 1 compared to a substance that has a pH of 2, this is the more acidic substance if it has a pH of 1, so it would have 10 times more hydrogen ions present in the substance with a pH of 1 versus the pH of 2. If I had a substance that had a pH of 3 versus a substance that had a pH of 1, this pH 3 is less acidic than the substance that has a pH of 1. It actually has 100 times less the hydrogen ion concentration as the substance with a pH of 1. Think of it this way. As I go from 3, or I'll go from 1 to 2 to 3, this substance is becoming less acidic as that pH rises. And then there's a power of 10 difference between each whole number in the pH scale. So there would be 10 times less hydrogen ions in something with a pH of 2 compared to something with a pH of 1. But if you wanted to compare something with a pH of 3 to something with a pH of 1, 10 times 10 means there's 100 times less hydrogen ions in something with the pH of 3. Okay, so let's try a couple let's practice problems, and then I have a shorter practice assignment for you to try yourself via Google Form. All right, so let's consider the following solutions. We have solution A, which has a pH of 12, solution B, which has a pH of 6, and solution C, which has a pH of 3. We're asked to place the solutions in order of increasing hydrogen ion concentration. If you want to pause the video for a minute and just take a second and think about it in your head, more power to you. If not, keep listening. All right, so increasing hydrogen ion concentration. As we get more hydrogen ions in solution, the pH should drop because more hydrogen ions means more acidic. This is the most acidic solution with a pH of 3. This is the least acidic solution with a pH of 12. The most acidic solution, solution C, should have the greatest amount of hydrogen ions. The least acidic solution, solution A, should have the fewest or lowest concentration of hydrogen ions. So putting these solutions in order of increasing hydrogen ion concentration, it should be CB. All right, these types of questions can be tricky, so let's read through this. It says when the pH of an aqueous solution is changed from 1 to 2, the concentration of, this should say hydrogen ions, the concentration of hydrogen ions in the solution is. Okay, so if I'm going from 1 to 2, the first thing I want to think to myself is this becoming more or less acidic? In this case, it's becoming less acidic because the pH is increasing. So if it's becoming less acidic, that means the concentration of my hydrogen ions should be dropping. So I'm going to go ahead and cross out C and D, which say that hydrogen ion concentration is increasing. Okay, so that leaves me with A and B. Is it decreasing by a factor of 2 or is it decreasing by a factor of 10? Well, remember, between every pH whole number in the scale, there is a difference of 10 times the hydrogen ion concentration from the next value in the scale. So what that is saying is a pH of 1 has 10 times more hydrogen ions in it than something with a pH of 2. So since we are decreasing the pH, causing this to become less acidic, we would see the hydrogen ion concentration decrease by a factor of 10. All right, last one, and then we'll see how you do on the practice assignment. Again, feel free to shoot the questions. It says, which change in pH represents a 100-fold, 100 times increase in the concentration of, again, just pretend that says hydrogen ions in solution. Okay, again, we're going to think of it this way. If I am increasing the amount of hydrogen ions in solution, I am making this substance more acidic, which means the pH should drop. So I'm going to go ahead and cross out choices C and D again. Oops, nope, no I'm not. I'm going to cross out, oopsies, A and B, because A and B have the pH going up, which means the solution is becoming less acidic. All right, so now between C and D. It tells me here I have a 100-fold increase in the hydrogen ion concentration. The correct answer is going to be D, because as I go from 3 to 2 to 1, again, between each number in the pH scale, there's a 10 times difference in the hydrogen ion concentration. Something with a pH of 2 has 10 times as many hydrogen ions as something with a pH of 3. Something with a pH of 1 has 10 times 10, or 100 times the hydrogen ion concentration as something with a pH. That's great. Okay, that hopefully helps a little bit as you try these practice problems. If you have questions, of course, send me an email. I'll try to sort it out with you through email. We can also plan to do a video meet. I'm definitely going to do one later this week, and I can get you some help with that. All right, I know I keep saying it, but I really do hope I see you soon. Bye.